This video, we're going to do a definite integral to talk about what you can do with secant. We'll also do an indefinite integral in one of the later videos that are, that's a little nastier. But the definite integral is a little bit easier. So we'll start with the easier version of secant. We'll do a harder version of secant in one of the future ones. And again, this is the worst one probably. That's not true. Secant integrals are the worst ones, but there's some cool problems in this section. I'm planning on doing a long selected homeworks problems video because there are some gems in this section. So look at the integral from 3 to 5, the square root of x squared minus 9. This is not a semicircle, right? This is y equals the square root of x squared minus 9. So y squared is x squared minus 9. So y squared minus x squared equals minus 9. Usually we write it as x squared minus y squared equals positive 9. This is a hyperbola, not a semicircle. Now I'm sure someone out there has a nice formula for the area under a hyperbola. Maybe it has calculus, maybe it doesn't, I don't know. But we're going to do this with trig subs. So, which trig sub are we going to use? I know there's a spoiler up here, but think of why. Go back to these three, and you should really just have these written down somewhere in this section. These tell you what trig sub to use. Okay? If you have something squared minus a number, that's going to be secant. So we can turn it into tangent. And something squared minus a number is exactly what we have. So we're going to let x be not secant, because if x is secant, this is what we're going to get. And there's nothing to do here. We need a 9 secant squared. So just like before, x squared has to be 9 secant squared. So we're going to let x be 3 secant. This is optional. You can jump straight to this if you see it. I'm just showing my logic for where it comes from. I always do this in my head. Even if I don't always write it down, I always think about it. And I'm writing it down to hopefully make things a little bit more clear for all of you. Okay? And again, the thing we're trying to use eventually is that tangent squared of an angle is secant squared of that angle minus 1. That's going to be very useful for us. As a side note, let's make sure this integral makes sense. Is the integrand make sense from 3 to 5? Yes, it does. When x is 3, we have 0, which is okay. And when x is 5, we have something positive in the square root, which is okay. This is kind of like a like the top half of a hyperbola. So it's not defined between -3 and 3 exclusive. But when x is at least 3 or less than -3, we're okay. Less than or equal to -3. All right, now the domain and range part is a little bit more interesting here. Because secant is weird. Okay, so what do we know about x here? Specifically in this case, x is between 3 and 5. Generically, x would be at least 3 or no more than -3. We'll worry about that case in a later problem. But here, we know that x is in the interval from 3 to 5. So the question is, what is secant going to be? And that's where things get pretty interesting. So theta start at 0, because secant of 0 is 1 over cosine of 0. 1 over cosine of 0 is 1. 3 times 1 is 3. The theta will start at 0, and then it'll go up to some number, but it'll be less than pi over 2. It's going to be some subset It's going to be some number. And this number doesn't matter because this number is less than pi over 2. Once theta is equal to pi over 2, we have a problem. We're dividing by 0. And sometimes theta will also be in this interval from pi over 2. So I think pi, yeah. We don't need this here. This is for negative x. Negative x will be the second part of the interval. We'll worry about that in a future problem. But here, we're just going to say theta is between 0 and pi over 2. What do we know about tangent on that interval is what we're going to need later. So domain and range. Sometimes the domain and range for secant gets messier. Sometimes you need this other piece. And it's actually not so important that we know what this is. We just know that we're in the first quadrant here for theta. Secant's a wacky function. So when we do the trig sub, what do we get? Well, this becomes x squared. Well, x squared is 9. Secant squared, theta minus 9. dx, oh, we didn't write that down. And we need our limits of integration too. Oof, lots going on. The dx is 3 secant theta, tangent theta, d theta. And if we change our limits of integration, we don't have to worry about putting anything back in terms of x at the end, which is great. Putting things in terms of x at the end sucks, which we'll have to do in a later video if we don't have a definite integral. But we're starting with just a definite integral. It makes things easier. So if x is equal to 3, what is theta? That's not easy. So let's do it on the next page. Right? If x is equal to 3, we know x is 3 secant theta. So what does theta have to be? That means, that means 3 is 3 secant theta. We actually already talked about this. The 1 is secant of theta. The 1 is, the reciprocal of 1 is still 1. The 1 is cosine of theta. When is cosine of theta equal to 1? Infinitely many places. But one such place is when theta is equal to 0. We do the same thing for 5. If x is equal to 5, then 5 is equal to 3 secant theta. 5/3 is secant theta. So cosine of theta is 3/5. And we'll use arctan. Or sorry, whoa, arc cosine. Theta will be arc cosine of 3/5. So that's actually what goes right here. And this is less than pi over 2. So that'll be our upper limit. Now it looks like a terrible integral. Have a little faith. Let's see what happens. So this 3 comes out in front. Integral from 0 to arc cosine of 3/5. We can factor out a square root of 9. And we're left with secant squared of theta minus 1. And we still have a secant theta, tangent theta, d theta. Now the square root of 9 can come out. Square root of 9 times 3 is 9. Integral from 0 to arc cosine of 3/5. Secant squared of theta minus 1 is tangent squared. Square root of tangent squared is absolute value of tangent. And this is where it really matters for the domain. Because if theta is in this interval, tangent's positive. First quadrant, tangent's positive. If theta is in this interval, tangent's negative. So the domain really matters for these secant integrals. But luckily, we know tangent's positive in this part. Tangent of theta positive or 0. That's good, because that tells us that we can combine these tangents and replace the absolute value with nothing. So 0 to inverse cosine of 3/5. And this becomes secant times tangent squared. Oh, remember we did secant and tangent integrals. Whoa, secant times tangent squared. Like that, right? Good. In the previous section, 3.2, how do we do these integrals? Well, we either tried to take out a secant squared, or we took out a secant tangent. Okay, this integral really sucks, doesn't it? Oh no. Oh no. I'm pretty sure this integral really sucks. Because taking out a secant tangent doesn't really help. Here, let's just write this. If we take out a secant tangent, we're left with tangent of theta. This is just scratch work off to the side. Times secant theta tangent theta. This is only useful if u is equal to secant. We can't have u be secant. So that doesn't work. And we can't take out a secant squared. We can't take out a secant squared because there is none. So we're going to have to use a Pythagorean identity on tangent squared. Okay, so tangent squared, right? Just like before, tangent squared is secant squared minus 1. This was a problem from the end of the section that I brought up because I was like, oh yeah, this will be easier than the other one. We got a little surprise though, a little bump in the road. Because look at this integral now. Integral from 0 inverse cosine of 3/5 times secant cubed of theta minus secant theta. This integral, no problem. It's the natural log of secant of theta plus tangent of theta in absolute value. No problem. This integral is a bit of a problem. This is that integral that we used integration by parts on. And I think we may have had to use integrate. Yeah, we used integration by parts twice to come up with this integral. But and then in that section they also introduced reduction formulas, and I skipped the reduction formulas. I said we're not going to worry about them because if I want you to do it, I'll just have you do it once and be done. But in a problem like this, for example, I am not going to have you do this in this sort of problem. Okay, I'm going to separate these two sorts of problems. If I, gave you this, I would give you the formula for sine cubed. Okay, so that's very important. So I'm just going to really quickly pull up the antiderivative of sine cubed because I don't want to go through and do that all again. You do need to be able to find it, but you don't need to find it within another problem, if that makes sense. So the integral of secant cubed, now that I've pulled it up, the antiderivative of secant cubed is going to be 1/2 secant of theta tangent of theta plus 1/2 natural log at absolute value secant theta plus tangent of theta. And then we're subtracting the antiderivative of secant, which is the natural log of secant theta plus tangent of theta. That's all being evaluated from 0 to that arc cosine of 3/5. Okay, so it's not as bad as it could be because notice that these terms actually simplify a little bit. We have plus 1/2 of one of these minus one of these is going to be minus 1/2 of these. We can kind of simplify these in this fashion. Okay. And now we don't have to put things back in terms of x because we already put our limits of integration back in terms of theta. Okay. So that'll save us a little bit of a headache. So what we're going to have is, it's still some headache. Okay. All right. We have 9 times the first guy, which is 1/2 secant of cosine inverse of 3/5 times tangent cosine inverse of 3/5. These aren't going to be as bad as they look if you remember your pre-calc. Minus 1/2 the natural log of secant of inverse cosine of 3/5 plus tangent of inverse cosine 3/5. So that's first part minus what happens when we plug in 0, which will be even better. When we plug in 0, that's just 0 because tangent of 0 is 0. Minus 1/2 the natural log secant of 0, and again tangent of 0 is 0. Okay, it's not as bad as it could be. Now let's just go off to the side. Or hold on. Copy this off so we have a little bit more room. Let's go off to the side and figure out what these guys have to be. We can do some triangles. We're curious, for example, well, secant is actually not too bad, right? Secant of inverse cosine of 3/5, well, that's just secant's 1 over cosine. And these are inverse functions. They cancel each other out. What's the reciprocal of 3/5? 5/3. This one's not bad. It's just 5/3. Oh, it's all here, right, as well. 5/3. We do still need tangent, though. Okay, and that one will be a little bit more complicated. So let's look at tangent of inverse cosine of 3/5. Now, inverse cosine is just some angle. We don't know what it is. And we do specifically know it's going to be in the first quadrant because 3/5 is positive. Cosine would be negative in the second quadrant. So since it's in the first quadrant, it'll look something like this. Cosine of some angle is 3/5. Use a Pythagorean, cosine, right? So cosine of that angle is 3/5. Cosine is adjacent over hypotenuse. Pythagorean for identity. The Pythagorean theorem gives us that the other side is 4. So tangent of that angle is just 4/3, opposite over adjacent. So it looked really messy, but look in this next step. Look what happens. The sun is finally coming out. All right, we have 1/2 times 5/3 times 4/3 minus 1/2 times the natural log. All right, this part's not as nice. Of 5/3 plus 4/3. And it's all subtracting. Oh, wait, should be parentheses here, right? We're subtracting this. So we're subtracting a negative 1/2. So we're subtracting so we're adding a positive 1/2. Secant of 0 is 1 over cosine of 0. Cosine of 0 is 1. Natural log of 1 is 0. Whoa, this is looking nice. I hope it's right. So what have we got? Let's see, simplify this. This becomes 2. Oh, that's it. That's 10/9. I like that it's over 9. Minus 1/2 natural log of 9/3, which is 3. Whoa, it's really coming out. Distribute that 9. We got 10 minus 9/2 natural log of 3. Is that right? We know what the answer should be. It's that. 10 minus 9 halves natural. That's good. That's good. That's the exact answer. Let me reiterate what I've been saying in all of these videos, everyone. Trig subs are great. Trig subs are cool. Please don't use them unless you have to. Okay? I had fun doing this, I'll be honest. But if there's another way, and think about this on the homework, and that's what the next 2 videos are all about, combining everything. If there's another way, use the other way. Trig subs are complicated, they're messy, they're exciting, they're fun, but they take a bit of time. All right, and use a bit of that one was a lot of pages. Let me know if you have any questions, and good luck. I believe in you guys.